Okay, my friends. So I'm going to get you in this video into this grouped data tab over here in the Excel calculator. We've been messing around with this raw data tab, which is just a really nice way of shortcutting some of the formulas that we use in statistics. The group data tab is also that way. It helps us shortcut the more messy formulas for the grouped average and the group standard deviation. A lot of times students just get so worked up about these formulas, and that's what they remember about stat. Like, oh, I hate statistics with all the formulas. And I'd rather not focus on the formulas. I'd rather focus on what the formulas are doing for us, what that end result of the formula implies for us. And that's what's so nice about the calculator, or any calculator for that matter, not necessarily just mine, is it takes the heavy lifting away and allows us to focus our energies on the interpretation. Okay, we're going to go through each piece of this calculator in this video. What we actually need is some grouped data, some data in a distribution. So let's look for data in a grouped distribution. Let's see what we come up with. Data in a group distribution. I spelled most of those wrong. Distribution. Let's see. Let's do a little image search here. All right, this isn't bad. Mean of there's that nasty looking formula. We got one here. People's age. You know what? Let's use this one. Let's use this one. We got some. There's a grouped distribution. We got people's age. 19 through 29 years. There's 21 of them. 29 through 34. 34 through 39. This looks pretty good. They've even given you a total down here, but my spreadsheet will do that for us. So let's actually use this one. A couple of interesting things I noticed about this data. The first thing is the categories don't cover the same number of years. For example, 19 through 29, that doesn't cover the same number of years as 29 through 34, right? 29 through 34 covers, if I'm counting correctly, I think that's 6 years. 29, 30, 31, 32, 33, 34. That covers 6 years, as does the one below it, 34 through 39, as does the one below that, below that, below that. And then 54 through 60 actually covers 7 years. 19 through 29, if I'm counting correctly, covers 11 years. So that's one little bit of a goofy thing. Why would you put the data in categories that are differently sized? I don't know. I don't know who collected this data. I don't know what this data is even of. So that's one thing to think about. I tend to like to make my histograms, when I develop them in bars like this, either have each bar have one thing in it, or have each bar have the same number of data points in it. But whatever, we're going to deal with it as it comes. So how do you put 19 through 29 into your distribution over here? Well, you have to put, as per our discussion from measures of center, we have to put one value from the entire range, 19 through 29. And the safest way to do that, as we discovered in our last lesson, was to use the middle, halfway between 19 and 29. And that, remember, why we chose that number is because it creates the least amount of error in the final summary statistics. The best thing you can ever have is the raw data. That way there's no error whatsoever in your data. I'm not talking about margin of error. I'm talking about actually misrepresenting your data and over-rounding up or down. So here, what's going to be halfway between 19 and 29? Well, if I add those two things together, I get 48. And if I divide that by 2, I get 24. So we're going to call everything in that category 24. Now, ignore everything over here on the left side of the sheet right now. It's going to be updating as we change our data in the distribution. Okay, back to the data. Next one up, 29 through 34. It's very early in the morning. I'm having a hard time thinking about what number is directly in between. It's going to be a decimal. So I'm going to have Excel help me out a little bit by doing 29 plus 34 divided by 2. I'm going to guess it's somewhere like 31. Yeah, 31 and a half. Back to here, I bet you this one's going to be halfway between, which is going to be 36 and a half. But let's just check using Excel because, again, like I said, my brain is not completely on right now. 39 plus 44, except that's not right, is it? I gotta go back and look. It's really early. 34 plus 39. Divide by 2. Yep, 36 and a half. Looks like they're going to jump up by 5 each time. I'm going to continue that pattern going. 46.5. I got to check over here. When do I stop jumping up? That's 46.5. That's going to be 51.5. Got to be careful this last one here. because this last one is not going to be the same as the other two, right? The other two, or the other, excuse me, the other 5. This one actually has one more data point in it. It's got 7 versus the 6. So this one's actually going to be 57. If you don't believe me, that's totally fine. We can use Excel to equals 54 plus 60 divided by 2. There's your 57. Okay, so again, just a quick note, you got to make sure you're picking the actual middle. That way you don't introduce any what's called non-sampling bias into your data. Okay, now we need the frequencies. 21, 10, 22. I can remember that. 21, 10, 22. All right, this is starting to develop a histogram over here. 22, 14, 11, 8. 22, 14, 11, 8. And then is there one more? 21, 10, 22, 22, 14, 11, 8. 22, 14, 11, 8. 22, 4. Oh! 22, 14, 11, 8. Man, it is early in the morning. I'm having a hard time keeping track of the data here. Okay, so there's our distribution. That's a histogram of this data, even though this data didn't give you a histogram. Maybe it does on the original source. I'm not sure, but Excel gives you one. I can look at this and say, okay, I can't really exactly tell where the average is, except for this bar. The data looks somewhat symmetric. If it were symmetric, the average would probably be somewhere right in here, but it might be a touch to the left of that because of where this bar is. I don't know. It doesn't matter because the calculator is going to give us our average and our standard deviation over here. It's also going to tell you the sum of the data, which you might remember that from over here. It actually told you this total was 108. Sum of all data. This one's a little bit interesting, and it confuses students at first. If there are 21 data points that are 24, 10 data points that are 31 and a half, 22 data points that are 36 and a half, and so forth and so on. If you added up all these data points with these frequencies, you'd end up getting 4,208 and a half as a sum of all the data. Now, if you divide that by that, you get this average that's up here. Okay, that's actually the same average you get right there. Last but not least, down here, we haven't talked about these measures yet. We talked about the median, I guess. The median is 41 and a half. And that actually makes sense that the median is a little bit above the average because the data is slightly skewed and the average is going to get pulled, like we said, a little bit to the left compared to where the median would be. Everything else in there we'll talk about in the next lesson, measures of relative position. So anyway, I hope this video got you started. The big thing to take away, though, if you have grouped data like this over here, for the data, for the X values, pick the halfway point for each category. And then the frequencies, just drop them in. And as the calculator gets data added to it, these update over here. I hope that helped. We'll talk to you soon.